While that's coming up, I'll mention that this work is funded by our TREX survey, and we have a pretty big team. So now that my title slide's up, I want to just mention the affiliations that are shown on the bottom. We have a pretty big team, and a lot of people contributed data to this effort. So the TREX survey is really focused on the fine particulates on the surfaces of solar system targets. In the middle top there, you can see a picture of, a picture of the moon, and then the Martian moons, and then an asteroid. And all these surfaces, to some degree, have very fine dust. So we want to try to understand the spectroscopy of dust so that we can apply that to the interpretation of remote sensing data from those bodies, which is what our objective is at the top. And we really wanted to focus on sub 10 micron particulates so that we could establish a spectral library that could be used for the analysis of data sets from a bunch of different missions. So we started with a set of 27 mineral samples, and they're all listed there with the bullets, and we have multiples of the samples that are shown there. We have olivines, pyroxenes, and then feldspars, oxides, sulfides, a bunch of phyllosilicates, and then we measured iron, metal, and graphite. Some of these samples are actually samples that are being used by other surveys, so, but we're looking at the fine particulates, so some of our data might be interesting to other surveys as well to compare to their coarser mineral spectra. So it was important for us to be sure that we understood the chemistry of our samples, because a spectral library is only as good as what you're putting into it, that you know what you're putting into it. So we've done electron microprobe data of all of our samples. And then, of course, because we're focused on the finest particle sizes, we needed to assure that we had what we were expecting. So with our minerals our coarser minerals that we started with, we shatterboxed them, we sieved them down to crushed and sieved down to sub 25 microns. But as you know, unless you introduce water, it's very hard to sieve to finer particle sizes. So we took that sub 25 micron particle size fraction, and then we just shatterboxed it to really pulverize our samples. But then we needed to know specifically what our particle sizes were. So we did particle size analyses, and what you can see is on the x-axis, 10 is at the right, and so most of our samples fell about 1 to 5 microns, so we know we're really looking at a very fine particulate sample. Here's a picture of what some of these sub 10 micron samples look like. This picture was taken when I took the samples over to Germany to do the spectroscopy at DLR. So we did the measurements at a bunch of different labs, and that was sort of the strength of this project. We measured all of our samples at the Planetary Science Institute, and we got UV and VNIR-MIR data from them. At the University of Winnipeg in Ed Clutis's lab, who's a co-I on TREX, in the VNIR-MIR. And then at DLR, in Jörn Helbert's lab, with the help of Alessandro Maturilli, we measured the samples in UV, VNIR-MIR, and mid-infrared wavelengths. So right here at CU Boulder, we're actually going to try to push our UV measurements into the far UV. These measurements, a lab is being set up by Greg Holzclaw here at the campus. And the goal is, and we think we're going to be able to get down to 120 nanometers. And right now our UV measurements cut off pretty much at about 0.2 microns or 200 nanometers. So that's to come, but we're looking forward to those data. So when you plot all of those spectra from all of the different labs, they're not lying right on top of each other, and they don't look identical, which is what you would hope would happen, but it just doesn't. So the spectrum, the graph on the right shows all of the UV, VNIR, and mid-IR data that we plotted from all of the different labs. And you can see more or less they look alike, but the overall reflectance is different. Some data have some calibration issues where there's a little bit of spectralon that wasn't corrected out, or there's slopes. Anyway, they just don't lay right on top of each other, which gave us the goal of trying to create a spectral library that represents the sample as accurately as possible. So what we decided to do was create what we're calling Frankenspectra. And so what that means is we're taking the best, we want to create one continuous spectrum that is built from stitching together the best pieces of spectral data from all of these different labs. So the way we did that is initially we looked at the 0.3 to 0.7 micron region in the visible wavelengths and averaged the data that we got to a baseline reflectivity. And then to that, we took the best pieces from all of the lab spectra and scaled and spliced the data to make what we're calling a Frankenspectrum. So this is a forsterite olivine, and this is what our initial group of data looked like. And now here is what our forsterite spectrum looks like. This is the same spectrum, but the left shows 0.2 to 2.5 in the visible wavelengths. And then we added the mid-IR on the right-hand side out to 20 microns, but it just compresses the other data in that graph. And we've done that for all of our 27 mineral samples. So here's sort of a yearbook page picture of all of the samples that we have so far in UV-Vis, and then here it is again out to the mid-IR. So all of these great Frankenspectra that we're making are going to be submitted to the PDS so that they should be available for anybody to use. We also are looking at a collection of meteorites. So here's the list of the meteorite samples that we have in hand. We got them during the pandemic, so I wasn't able to go to DLR to do the measurements. Oh, sorry, before I get to that, here's, to whet your appetite, here's what our samples looked like. And we did, because we had these nice slabs, we did the measurements on both sides of the slab. And then we decided also to keep a coarse particulate sample as we marched our way to this fine particle size samples. So we have a 63 to 125 micron sample, as well as these sub 25 or probably closer to sub 10 micron samples that are shown in the little cups below the images. So we had to employ other labs like Relab, which provided us with the VNIR-MIR and mid-IR reflectance data. Then we also added Stony Brook University, which enabled us to add a graduate student to help us with this too. And again, Ed Clutis provided the VNIR-MIR spectra. So right now we're still sort of in compiling mode, where we're still hoping that we can get some sample spectra from DLR and also from the Planetary Science Institute. So we're kind of compiling our data now and haven't gone through the whole Frankenspectra process with these, but they will be coming soon. So in summary, the solar system is full of really dusty targets, and to interpret your data, you really kind of need to look at a spectral library that has similar sized particles. So that's the objective of what TREX is doing. A lot of the cross-lab comparisons also really illuminated some differences in the labs, and it has helped us do some hardware corrections and calibration corrections, and I think it's elevated all of the labs together. As far as that goes, we're also developing some new UV calibration targets that once we get them done really well, we'll make a handful of them and distribute them to some labs that are doing UV measurements. But these Frankenspectra should for the minerals, should be posted to the PDS hopefully by the end of this calendar year. And we're pushing down, we're waiting for the far UV spectra, so we want to add that to it. So there's been a little bit of a delay, but hopefully that'll be ready to be attached to our splice to the Frankenspectra very soon. And one thing I want to mention is that we're also awaiting lunar samples. We have a sample suite that we requested, and I believe it's been approved. We just haven't received the samples yet. So we'll also have lunar samples. And we're doing some other things as well with mid-infrared emissivity measurements and Raman and Mossbauer and things like that. So ultimately, the mineral spectra, the meteorite spectra, and lunar spectra that are really fine particulates will be available for the use from other labs to apply to past, present, and future missions. So we hope that they're useful for all of you too. Thank you.
So we have time for one quick question.
Mike Lucas, University of Notre Dame. A very nice presentation. I'm curious about the meteorite spectra, and I noticed a lot of Antarctic samples. And so was there any attempt to clean up terrestrial weathering? And can you comment on the weathering grade? And, very important when you're producing powders.
Right.
Yeah.
Let me go. So here's an image of that. So when we requested our meteorite samples, we requested that we get as unweathered of samples as possible, because you can see even on some of these, there's some, sort of iron staining weathering. But we get what we get, and we waited a long time for them. So we're hopeful that when we first crushed them, you can pull out the pieces that look like they're weathered the most and kind of exclude them from your sample. But then we just crush them and hope that all of any sort of weathering issues are really swamped by the pure signal of the minerals. So we did request, avoiding any kind of weathering.